Hello, everybody. This is the second part of chapter 1.5, and we will talk about non-homogeneous systems. So last time we talked about the homogeneous systems, basically systems which has a right-hand side equal 0. And we found that those systems, if you have a free variables, then they have a solution equal t, which is any number, absolutely any number, time vector v, or a linear combination of vector v, or span of vector v. So that was very convenient and easy to interpret it geometrically. So today we will try to expand this result into non-homogeneous system. So the system AX is equal B, where B is not actual 0, so B can be vector of any numbers. In this case, we can actually have the solution which is kind of similar to our homogeneous case. So we again have a X is equal a linear combination of number t times vector v plus another vector called p. We often see that there is a p-corrected solution. So we correct it by another vector p. And it probably sounds very confusing right now. So let's just work through example and see how we can get this strange form. Okay, so let's look at the system of non-homogeneous system Ix is equal B, where matrix A is exactly the same as we looked in part 1, and vector B is non-zero anymore. It actually have 3 numbers in it. So let's try to find all solutions, and our strategy will be very similar as we try in the first chapter. We will write down augmented matrix, we'll reduce it to echelon form. If we will see an empty pivoting column, we're lucky, we have free variables and we probably has the solution will exist. Then we will try to find this solution and write it down in parametric form. Okay, let's start. So we will write down an augmented matrix, which is, by the way, it's just our matrix A, and we just add the vector B as an extra column to the right. Okay, so now we will go ahead and reduce it to the echelon form. And since we are reduce this matrix to the echelon form in the part 1, I won't go into all details. If you're not sure how did I get to this echelon form matrix, please go to the part 1 and check all details. But okay, so now we have our matrix in echelon form. And again, good news, our third pivoting column is missing. So we are lucky, our variable x3 is free. So we are guaranteed of having a solution. However, it does not want her to test. So let's look at our bottom row. It gives us an identity 0 equals 0, wonderful. So let's go one row up. That row will give us x2 variable is equal to, wonderful. So in the first column, give us an equation which include variables x1 and x3. So it will worth writing down our variable x1 in terms of the free variable x3. Wonderful. And again, so far, it's probably looked very similar than to part 1. And we will continue with the same strategy with tiny differences, which I will point out later. But let's continue by writing down our solution as a vector. So vector x has a 3 component, first x1, second x2, and third x3. So let's go ahead and plug our vectors, our solutions here. x3 is our free variable, so we just write it down as x3. Value of x2 is equal to, and x1 can be expressed in the terms of the variable x3. And in part 1, we had a little bit simpler case because we could easily factor x3 and write down it as a linear combination. here we cannot quite factor out x3 because it has this free term -1 in the first row and 2 in the second column. So we need to do some extra work. What if we will take this vector and separate it into the 2's? One of them will contain free terms like -1 and 2, and another one will have a x3 terms. Okay, so let's do that. So our first row will give us free term -1. The second give us free term 2, and the third one does not have a free term, so we will put 0. And for the second vector, we will put our all remaining terms for x3, which is second row. Second row does not have a x3 term, so we will put 0 here. Okay, now we can go ahead and factor out x3 from this second vector. And again, we are clearly looking at the linear combination here and some kind of vector. So let's give them a name. So let's call our new vector consisting of 3 numbers. Let's call him P. And for the second vector, the one which form a linear combination, we will call him V. So basically we can write down our solution now in the vector form. Vector x is equal vector P plus weight x3 times vector V. And again, this is the parametric form. And just to stress out that x3 can be absolutely any number, we will replace this by parameter t. Just in our mind, we would know that there is anything can be our parameter t. So again, this is our parametric solutions, and it's actually make a really interesting geometric interpretation. So when we have a homogeneous system, like right here, the black line here, it is formed by the linear combination of vector v, like we call it TV. So basically we extract or contract vector v or put it in opposite direction. There is this nice line. But now when we have a non-homogeneous system, we can take every single point of our line and shift it by the vector p. And this line, this new blue line, will form a solution for non-homogeneous system. And there is a lot of interesting example of interesting geometric interpretation and more thorough information on the solution of non-homogeneous system in the chapter 1.5. So I would like you now to go ahead, read the chapter 1.5 one more time and work through several examples before you start practicing problems for quiz 2.